All right, so for our first reaction here, we got calcium reacting with sulfur, which is what kind of a reaction? It's a synthesis reaction. All right, so we're going to produce an ionic compound in calcium sulfide. Doing the numbers and adding them. No. Okay, so we got a drop and swap here, guys. Okay, this is -2, this is +2. Okay, so we got that's properly balanced. Okay, so now we got to balance the reaction. So we got sulfur here, but there's 8 of them, so I got to put an 8 here and an 8 there. All right, so you give them 1 mark. If they had calcium sulfide, actually give them 2 marks for the product. There was only 1, but give it to them anyway. Okay, and 1 mark for the balancing. All right, for number 2, we have a hydrocarbon reacting with oxygen gas, which produces what? CO2 and water. Okay, so we've got 1 mark for carbon dioxide and 1 mark for water. Do I need both special balancing rules for this reaction? Just the first one, just balance alphabetically because that's not an even number. All right, 7. 8 times 2 is 16. Okay, now looking at the oxygen, 7 times 2 is 14, plus 8 more is 22. All right, 11 times 2 is 22. So 1 mark if they got the balancing correct. Okay, for question number 3, we got a double replacement reaction with lead nitrate reacting with sodium chloride. Okay, what do we do in a double replacement reaction? Swap the metals, right? So that means that sodium ends up with nitrate and lead ends up with chlorine. Now, which lead is it over here, 2 or 4? 2. All right, so over here, okay, we got to drop and swap 2 plus and 1 minus. So we got PbCl2 on that side. Okay, so now looking at the balancing here, sorry, this one's already dropped and swapped correctly, so give them 1 mark for sodium nitrate and 1 mark for lead 2 chloride. Now we got to balance. On this side, there are already 2 nitrates. So I'm going to put 2 nitrates on that side. That gives me 2 sodiums, so I got to put a 2 here to balance the sodiums, which then gives me 2 chlorines, and there's already 2 over here, and there's only 1 lead on either side. 1 mark for the balancing. Okay, for number 4, we got iron and copper. Which copper is this? 1, copper 1 sulfide. Okay, so what kind of reaction is that going to be? Single replacement. Okay, who is iron going to replace? Copper. All right, so it doesn't really matter that it's copper 1 because copper ends up by itself anyway. Okay, now what does matter is that we don't know which iron this is. Okay, so we use the most common, which is 3. Okay, so we're going to have 3 plus and 2 minus, so this is going to be Fe2S3. Okay, so 1 mark for copper, 1 mark for iron 3 sulfide. Okay, and then we got to balance everything. So on this side I have 2 copper, but if I put a 2 over here, that's not really going to work. Okay, on that side I've got 3 sulfur, but if I put a 3 here, that's probably going to be okay. Okay, so let's put a 3 there. How many copper does that give me? 6. Okay, how many iron do I need here? 2. Okay, all right, so 1 there. All right, so each one of those was out of 3 marks, eh? Okay, question number 5. We have to calculate the mass of 12 moles of iron 3 bromide. Okay, so we got to write down our givens first. 12 moles is which part of the mole equation? N. All right, so we got 12 moles. And then we have iron 3 bromide, so that'll allow us to calculate big M and iron 55.85. Okay. Okay. Plus, we got 3 bromines, so 79.9 times 3. Oh, 55.85 plus 79.9 times 3. Okay, it's 295.55 grams per mole. Okay, so now I've got N and I've got big M. Do they have the 295.55? Yeah, this is just part of the given, so okay, they're only getting really 1 mark for this part here. All right, then they have to use the mole equation. N equals little m over big M, but we're solving for M here, so we have to do a manipulation. Okay, to move big M over to the other side means I need to multiply both sides by it. So I got big M times N equals N, or sorry, equals M. So give them 1 mark if they showed that manipulation somewhere. Then we got to plug in our numbers. So we will have 295.55 times 12 moles. Okay, so give them a mark for plugging in the numbers correctly there. All right, gives us 3,546.6. And what are our units? Grams. Okay, they must have the grams there or the answer is wrong. Not half off, it's just wrong if it doesn't have the right units. Okay, so that one is out of 4 marks. Yeah, if they have 3.5466 kilograms, or I guess you would have rounded, yeah, okay, I'll take that in the future. Grams is better in chemistry. We get to physics, we do things big, then we'll use kilograms. Okay.